When you think about space travel, what comes to mind? Probably roaring engines, right? Just incredible force. But what if I told you the reality is something, well, something far more beautiful? It's less about fighting the universe and a lot more about learning to perform this elegant cosmic ballet. And that simple, profound shift in thinking is exactly what we're going to explore.
This one idea, it's pretty much the heart of everything we're talking about today. We're going to see how every single successful space mission, from the moon landing to the probes way out at the edge of our solar system, is a masterclass in working with the fundamental forces of nature, not against them.
Okay, so this is where we have to throw out everything we've learned from the movies. Seriously, science fiction always shows us these ships flying in perfectly straight lines with their engines just blazing. The reality? A spacecraft might fire its main engines for just a few minutes, and then nothing. Just silent coasting for months or even years, following these invisible, curved pathways through the void. So how on earth does that actually work?
All right, so to really understand this cosmic dance, we first have to learn the steps. And it all starts with understanding the fundamental rules of the road. Because in space, the highways are totally invisible, and they're paved by gravity itself. And this is such a great way to picture it. Imagine the universe is a giant stretched out trampoline. A massive object like our sun is like a bowling ball you place right in the center. It creates this deep curve in the fabric, right? While planets and our little spacecraft, they're like marbles rolling along that curve. They aren't being pulled by some mysterious force. They're simply following the contours of space-time. Now, this creates this beautiful paradox. On Earth, everything slows down. But in the vacuum of space, once you're moving, you just keep moving at that exact speed, in that exact direction, pretty much forever. So the crucial point is, the hardest part of space travel isn't staying in motion. It's starting, stopping, or trying to change your direction. Just think about that for a second. The space shuttle's main engines burned for just 8.5 minutes. That was the battle. After that, weeks in orbit were spent in the glide, just carried along by momentum. The vast, overwhelming majority of any space journey is a silent, powerless coast. So if you're not constantly firing your engines, how do you get anywhere? Well, this is where the genius comes in. Engineers have developed some incredibly clever techniques, making space travel less like driving and more like surfing a cosmic ocean. Take a journey from Earth to Mars, for example. You don't just aim for where Mars is and hit the gas. No way. Instead, you do a short engine burn to push your spacecraft into this wide elliptical orbit around the sun. And then you just coast for months until your path perfectly intersects with where